Hi, in this video we will see how to use the powers of a complex number and how to calculate, without doing much of calculations of, with hand. So I have a complex number z is equal to a plus ib. Now I'll convert this into it to the polar form, which we have already done this. Now let's say I want to calculate z square, meaning I'm interested in, okay, now this can be written as, now I can write these, each one of them into the polar form. Right, now I can do r square. Now already we know that when I have to multiply two complex numbers using polar form, we multiply their distance from the origin and we add the argument and the modulus. So you get r square. So the answer is 2 theta. So z square is r square is 2 theta. Now let's try if I want to do, let's say z cube. That means I'm interested in. Now what I'll do, I'll write z cube as, right? Now a plus ib square I already know from the previous result, so I can directly use this. So what I'll do, I'll substitute this as r square, so this 2 theta, and this I'll write as r theta. Now again using the product, this becomes r cube. This is r cube 3 theta. So z cube is r cube is 3 theta. So in general, I can say for any complex number z to the power of n, if I want to calculate its nth power, the answer is nothing but r to the power of n is n theta. So this in general it is true, and this is also called as the Moivre's theorem. The Moivre's theorem. The Moivre's theorem. Now this becomes helpful in calculating the higher powers of n. If let's see that for an example. Let's say I want to calculate 1 plus root 3 I whole power 6. Let's say we are interested in this. So first thing what I'll do is I'll simplify, I'll convert this into its polar form. So for that, let's have a given a representation of the Argand diagram. So if I compare this with, this is my rough work. If I compare this with a plus ib, my a is 1 and b is root 3. Okay, this is our some simple rough work. So a is 1, that means I can, not to scale, I mean, so I can say, somewhere roughly around here. So let's say this is my point, 1 comma root 3. Now next thing what I'll do, I'll join this and calculate the modulus and the argument. This is theta, and clearly we know that this is my 1 and the perpendicular distance, and that means the perpendicular here will be root 3. Now tan, not sorry, not tan, uh, sine theta will be root 3 upon, now let's call this distance r. We can calculate the value later, r, and cos theta will be 1 upon r. So using distance formula, r will be 1 square plus root 3 whole square. So r is square root of 4. That means r is 2. And now since r is 2, I can use tan theta now to give me tan theta will be root 3 upon 1 perpendicular upon base or opposite upon adjacent, whichever the way you feel it comfortable. So which means theta is tan inverse of root 3. Some people use arctan, I mean that is up to you, which gives me theta is 60 degree, or in terms of pi it becomes pi by 3 radians. So therefore my polar form will be r is 2 cis pi by 3. Okay, this part I have just done for our understanding, so that we know that we are substituting when we convert it to polar form. So this need not write. I mean, you can directly start from this part here, and you can directly reach here when you're writing it. This you don't have to write if it asked in an exam. Now what I want to know z power of 6. So z power of 6 will be 2 cis pi by 3 power 6. Now we already know this is nothing but 2 power of 6 cis 6 into pi by 3. And 2 power 6 is 5 is 32, so 6 is 64 cis 2 pi, which is nothing but 64. If I convert it, cos 2 pi plus I sine 2 pi. Now cos 2 pi is 1, cos 360 degree, add sine 360 is 0, so the answer is 64. This is your z power of 6. Okay, so this is how we can calculate different powers of number for different complex numbers using De Moivre's theorem. So first thing is convert the given complex number into its polar form, then using it for the necessary power, you do it, apply it on the modulus and the argument, and that's the answer. So if you have any doubts, please let me know. Till then, take care and have a good day.